Let us talk about this problem. We are given an array and three indexes in it. Indexes are low, mid and high. We are given that elements from low to mid are sorted and elements from mid plus 1 to high are sorted. For example, low is 0 here, high is 4 here. Elements from low to mid means 0 to 2 are sorted and elements from mid plus 1 to high are sorted. We need to sort the array from low to high. Right, so we basically need to merge the sub-arrays. We need to merge this sub-array with this sub-array and we get this. In this example, low is 0, mid is 3 and high is 4. So we have sorted array from sub-array from 0 to 3 and 4 to 4 is also sorted. So we need to merge these two and we get this one. So basically, we are given three indexes in an array and low need not to be 0. That's why I've used dot dot dots here. And high need not to be the index of last element. That's why I've used dot dots here as well. So I'm given low, mid and high. Low to mid sorted, mid plus 1 to high sorted, and I want to sort low to high. We are also given this low is smaller than equal to mid and mid is smaller than high. What it means is there is going to be at least one element from low to mid range and there is going to be at least one element from mid plus 1 to high range. See, we have low to mid, that's why we allow equal to here, right? And mid plus 1 to high, that means we should have the greater sign here to allow one element. Now please pause this video and try to write down a function that takes an array as an argument, takes three indexes as argument. Your function may assume that your array has at least two elements, right? This condition is followed, right? And the indexes are given in such a way that they follow this rule. You may also assume that elements from low to mid are sorted and mid plus 1 to high are sorted. Your task is to sort the subarray from low to high. Let us now talk about the idea to solve the problem. What we are going to do is, we are going to follow the same idea as we've discussed in merge two sorted arrays. There we were given two sorted arrays and we want to produce the merge thing on the output screen. Here we are given the same array and we want to merge two sub-arrays of it. So what we do here is, to solve it in a similar way, we create two auxiliary arrays left and right. Size of left array is chosen in such a way that it can store the elements from low to mid. Right is chosen in such a way that it can store the elements from mid plus 1 to high. Once you create these two arrays, you copy the elements from low to mid to left. You copy the elements from mid plus 1 to high to right. Now you simply need to write the same logic that we wrote in the merge two sorted arrays. The difference here is, there we were printing on the output screen. Here we need to put the merge part back into the original array. So now you have the complete idea what all we need to do in this function. Please pause this video and write the complete function yourself. Here is implementation of the merge function. We are going to use this function as it is in our merge sort implementation. What are we doing here? We are first getting the size of left array. See, if you are given this array, low is 0 and mid is 2, the size of this array is going to be 3, which means mid minus low plus 1. And size of right array from mid plus 1 to high is going to be high minus mid, which means 4 minus 2, 2. So we get the size of left array, size of right array. We create two arrays, left and right. We copy the first n1 elements of our given array to left. We run a loop from 0 to n1 minus 1 and copy the elements starting from index low plus high. See, this is important. Low might not be 0 all the time. The reason is, we are going to use this merge function in the merge sort, and merge sort would call this merge function for intermediate subarrays also, where low might not be 0. After copying the n1 elements from array A, first n1 elements from array A, then we copy the remaining elements from array A. So we are going to beginning copying from n1 plus I, right? And I is going to go from 0 to n2 minus 1. So we have first n1 elements in left and then n2 elements in right, and n1 and n2 are these and these values. After you have built the left and right arrays, your logic is same as what we have discussed in the previous video. So I'm not going to discuss this in detail. This is something we have already discussed, the standard merge function. There in the previous implementation, we were printing the elements in the merged order, here we want to store them in an array A, right, in our original array A. So we are using an additional index variable k, right? Instead of printing left I on the screen, we are going to store left I in AK, and we are going to increment this index k also. Here also we are storing this element right j into AK in this case also, and we are incrementing k++. And whatever elements are remaining in either left or right, those elements are also going to be copied to the array A, right? And k is always incremented. K is all the time incremented in all loops. So if you are given this array, this part of the code is setting up left and right temporary arrays. So after you execute this part, your left and right arrays would be this, and this part is now merging left and right arrays into an original array A. So after this part, your A will become this. This was your input A, and now it becomes A. These two sub-arrays are merged. Now the time complexity of the solution is clearly theta n. N is the number of elements from low to high, right? So we have discussed this in the previous video that this overall runs n times, and this part is also theta n, right? N1 plus n2. Talking about the auxiliary space is also theta n, n1 size of left and n2 size of right.